So hello guys, again. So this is Adav. As I already told you, we are now in the motion part 3. So I finished the first two. I couldn't be able to finish, the last acceleration part. That was actually given a homework to you. Try to solve the homework. So that is all about it. So today in this video, we are going to see about motion, which is actually the part 3. Basically, we are going to see about some of the important concept. The important concept is that the three Galileo's equations of motion and the wrong misconception which has actually been taking place. I need to, resolve that. That is something very important. But as I already taught you about the acceleration, a quick check or a quick revision. Acceleration is basically v minus u by t, or basically change delta v by t. We usually use the delta for change in, that is what is used for delta, change in velocity by time. Very important formula, very useful formula, because this formula we can use it to derive derivation for one of the Galileo's equation, one of the Galileo's equation of motion. So let's get straight away. One of the important concept is that for uniform acceleration is basically, suppose a particle is moving with a uniform acceleration. Suppose the particle v minus u by t has a u is uniform, same acceleration throughout. Then there is another formula for average velocity. As we already said, average velocity is basically total displacement by time. The another formula is v plus u, which is final velocity plus initial velocity by 2. Very important formula. Very, very important formula. So here, with this, we can actually derive the rest of the two equations of Galileo's. So this is the base. Now let's get started. So as I already told you, very important concept. Please learn this very well. Used in many JEE questions and all. For the next motion part 3, I will be taking a motion reversal. Before getting started, let's get let's start the common misconception used. Many people assume that opposite of acceleration is deceleration. This is absolutely wrong. Deceleration is basically slowing down. Acceleration, so opposite of deceleration is actually speeding up. Acceleration is a whole different thing. Acceleration basically accelerating. Opposite of acceleration is uniform motion or being in rest. That is also uniform, right? Or being in rest. This is the opposite and not retardation or deceleration. This is definitely not the opposite. That is something which is very important to understand. Many people usually, have keeping in mind that actually the opposite of acceleration is deceleration. That's absolutely wrong. Yes. So let's straight away derive the formulas. As I already said, u equals v minus u by t. So v is basically equal to, if you take the t in that side, it is basically u plus at. This is one of the formulas. There is also another formula which can be easily derived by using this u plus v by 2. This formula is used for uniform acceleration. Here we know that v is equal to u plus at. From this we can use this. So u plus at by 2, which is basically u times u plus u, so u 2 and 2 gets cancelled. So u plus half at, because we are taking the 2 outside, is basically equal to average velocity. This is also a very useful formula. I will be coming back to that later on stages. So now, if you want to find the distance, is basically average velocity into time. So basically u t plus half a t square. So with this formula, we can also find the third equations of motion, which is 2as equals v square minus u square. This is also very important formula where S is the displacement, A equals the acceleration, V equals the final velocity, U equals initial velocity. So it's a very important formula. So I'll be writing these three formulas clearly here. First, let me write acceleration equals V minus U by T. Then average velocity equals V plus U by 2. Average velocity into time equals distance. And 3 equals V equals U plus AT. S equals UT plus half AT square. And 2AS equals V square minus U square. So all of these formulas are something very important to understand. So now let's try to solve a question. Very important question. So usually this for this question is, wait. Suppose a particle is starting with the initial velocity of 3 meters per second to here going with velocity 5 meters per second, having an acceleration 1 meters per second square. Find the time it takes and also find the distance it moves, or find the S. So this question is very easy to understand because acceleration equals V minus U by T. Acceleration is 1 meters per second. 5 minus 3 by T. So T is basically 2 seconds. Very easy. If we have T, which we already found, basically S is basically equal to 3 times the 2 UT plus half A basically 1, so we leave it 4. So this is basically 2, 6 plus 2, 8 meters. This is the answer. So very simple sums, very easy to understand. For a free falling object, we use acceleration as g, which equals 10 meters per second square. That's all guys, very simple concept to understand. You will be able to understand a lot of this. Thank you friends.